Hi Andy, good morning. This is again Dr. C.H. Kiran Kumar dealing you the machine learning part. Right, today let us see what is called SVM, support vector machine. Right, before going to that, let me just revise what is called Perceptron. Perceptron. This is the algorithm we used for Perceptron. This is where whichever is outlier, only the outlier formula is this. Only the outlier when it is considered as an outlier, then its weight is added to our W. Then we say converge is equal to false. If there is no outlier exists, then it comes out of the loop. If there is even at least one outlier is identified here, automatically this while loop, the outer while loop, will definitely will ask you to execute the same for another time. This is called perceptron, adding weight when an outlier is there. Okay, outlier unnappudu. Outlier means, what do you mean by outlier? Which is far from our assumption. That is called outlier. All such outliers are taken into consideration. Such outliers are given some weight. That is how we calculate this weight vector. Hope you understood, my dear friends. Thank you. Right, next one is similarly here. In this case, these are all called outliers, right? In this case, right, this is called dual perceptron outlier. Dual perceptron. The only thing is the formula of finding a outlier is different. This is what is different. And then if this is the case, we just use alpha I. Alpha I is equal to alpha I plus 1. This is the formula. Alpha I is equal to 0. Now, for each outlier, we are calculating this. In the previous case, we used to calculate only one W for everything. But here we are separating, and for each outlier, alpha I is being calculated. This is the difference between dual perceptron and perceptron. Coming to the perceptron regression. Now we can use this perceptron for regression. How? Labeled training data D, and then we have to calculate the weighting vector. Now W is equal to 0, T is equal to 0, while T is less than T. For I is equal to 1, this is our right. W plus YI minus YI hat whole square into Xi. Then this is how perceptron can be used for regression. Perceptron can be used for regression, my dear friends. Regression. Now let us move on to what is called support vector machine, SVM. Let us see some linearly separable. What do you mean by linearly separable? Suppose, let us take two independent variables, x1. This is an independent variable. This is another independent variable. Let us see the classes. There are two classes. One is filled circles. Another one is empty circles. Now, the thing is, we need to find a separate, linearly separable. These two have to be. Can you separate these? And if you can see, this line separates these two. This line also separates. This line. Now, if you take a line like this is a bad line, which correctly separates it. This is a right line. This is also a right line. See, you can say this is also a right line. This is also a right line. Now, among these correct lines, which line is considered as the best? What is called best here? What is called best here? There are training data and test data. Right. This is all called training data. This is all called training data. For suppose in test data, for example, one filled circle, suppose comes here. In test data, my dear friends, then which line determines that correctly? This is the question. Which line, whether this line, which line now, this line is bad line now again. This is correct line. This is correct. So this is also correct. No, this is called best line. This is how we have to determine which line is the best line. Which line is the best line. This is what SVM is. SVM, support vector machine. Let me just give you an idea of how do we calculate this. So first find out a line which crosses this particular class, and you take another line which crosses this particular class crosses. This is called touches, and this margin, this is called margin. This is called margin. And you can have any number of lines. This is one line, this is one way, this is one. And see, similar lines can be, any number of lines can be written like this. For example, see this. This is another line. This also touches this, and touches this. This is called another margin. See, previously we called it margin 1, and this is called margin 2. Now we can have another line. Any number of lines can be written like this. In this fashion, any number of lines can be written. Any number of lines can be written like this. Any number of lines can be written like this. This is called margin. Right. When you able to find out margin 1, margin 2, margin 3, margin 4, margin 5, then which margin is to be considered as the best margin? There is no doubt whichever has highest margin, maximum margin. Maximum margin is the best one. Then what is the line? What is the separating line then? The separating line would be the center of it. The center of it. Just center of it. For example, if this is the case, see this. Suppose this margin aite, if this is the margin, then we will be taking the center of this as our separating line. This is called separation of linear. This is called linearly separable. linearly separable. Now, what do you mean by not able to separable? Unseparable. అంటే ఏంటో చూద్దాం. See here. If you take this as consideration, now our independent variables are at x1 on x-axis, x2 is at y-axis. Now, if you see here, so there is a white, no, empty cell here, and the filled cell here. Now, how do you separate these two? There is no possibility. See, if you separate this, if you try a line, see, this is wrongly predicted, this is wrong, and this is also wrong. This is called, these two are called, no, beyond our line. Now, not in cross their crossing margin. We say they are crossing the margin. We used to say these two are crossing the margins, Then what to do? Then we have to calculate what is called loss. This is also called hinge loss. Before going to hinge loss, let me just tell you, no, see, we have taken this as maximum, right? Now, in other words, maximum of margin, right? This is called max of margin. In other words, can we say just min of 1 by margin? See, for example, you take the distance is, no, 2, 4, some 5, some 8, for example. Now, maximum is 8. What is 1 by 2? What is 1 by 4? What is 1 by 5? And what is 1 by 8? And what happens if I say min of 1 by 2, 1 by 8? So definitely both are same. Max of, no, even if you say max of 2, 4, 5, 8 anna, min of 1 by 2, 1 by 4, 1 by 5, 1 by 8 anna kuda rendu almost similar. So in this case, we will take this, no, whichever is convenient, we will go with that. No, one method we will go with is, no, one method is we will go to the maximum of margin or minimum of 1 by margin. Hope you understood, my dear friends. So these two terminology is not very difficult, right? Anyhow, so let us see now how do we calculate the hinge loss. Only see, whichever, no, let us calculate, no, for whichever, see, we are not able to predict this correctly, right? Similarly, margin, we are not able to correct this correctly, right? Calculate the distance, calculate the distance between only the faulty ones. Calculate this distance, and similarly this distance. Calculate the distance there. Let us call that as loss or lambda. See, now we'll see. Let's call this as penalty. This is called penalty. That is called, let's call this as a penalty, my dear friends, penalty. Then how do we calculate now? See, for example, now we'll use this method, minimum of One second. See, penalty means penalty. This will have some penalty. This will have some penalty. So now our function would be minimum of 1 by margin plus lambda times into penalty. As there are number of points, we have to use, right, sum of. So our function would be min of 1 by margin plus lambda times penalty. Hope you understood, my dear friends, right? Now, right here, we call this as hinge loss. Hinge loss. What is meant by hinge loss? Hinge loss means, hinge loss is this penalty is called hinge loss. How do we calculate this? Very simple, hinge loss. See, hinge loss is 0 of a point is 0 if it is right. If it is right. This is 0, this is 0, this is 0, 0, 0, 0. This, for this hinge loss is 0. For all these things, hinge loss is 0. But whichever is not separable, those two will have hinge loss. Hinge loss is less than the distance. Is less than the distance. That is, if let us now see if it is correct, if correct, then loss is 0. If not correct, proportional to distance. Very clear, right? Now let us see. See, our formula is minimum of 1 by margin plus lambda into sigma penalty. Penalty is nothing but the distance between these two. The boundary, the distance between these two. This is called penalty. Right. Now, if you see here, this is lambda, my dear friends. This is lambda. Now, if you see here, this is penalty. And see, we don't know, no, when we talk about classification, we need to have a variable like this so that if I vary this and this gets varied. Now, for which variation it gives us correct result, that variation is taken into consideration. For that, we use a multiplier called as lambda. This is called penalty. Hope you understood, my dear friends. Right. Now you can clearly see how even unseparable data can be considered in a support vector machine, SVM. This is called support vector machine. But still, it has some drawbacks. Still it has some drawbacks. Now, let us see. If the data is linearly separable, So finally, we can say if the data is linearly separable, we can select two parallel hyperplanes, right? Now, if it is two-dimensional, we can easily visualize it. Three-dimensional, we can visualize it as a as a plane, as a plane. But it is, if it is having more than that, we cannot even visualize that. Right? Anyhow, whatever it is, right? Now, if you have select two parallel hyperplanes that separates the two classes of data, so that the distance between them is as large as possible. This part and this part. This must be as large margin. This must be as large as possible. Now, the region bounded, these two are called margin. And the maximum margin hyperplane is lies half, just half, middle of that is called. When data is not linearly separable, data cannot be linearly separable, then you have to take what is called penalty. Penalty for crossing over. Evaraithe cross chestam. Whoever crosses the margin, whoever crosses the boundary, they only will be calculated. No, this positives here, negatives here. Now, if some negative is there here, that this negative has been crossed the margin, we say. And if some positive is there, we say there is a plus cross this margin. For such crossed margin, crossed ones, we calculate what is called penalty. Is nothing but distance. Is nothing but distance. This distance. This is the distance. This is called penalty. Now this is called hinge loss. Hinge loss. What do you mean by this? Hinge loss? No, hinge loss is equal one minimum of 1 by margin plus lambda times this distance, sigma this distance. This is called penalty. Now quickly let us see now the drawback of this support vector machine, which cannot be linearly separable. For example, for suppose a simple case, just take a simple case. This is a simple one. See, for example, this is 0. Now let us see some points are here. Some points are here. Some are here. Right. Now some other point, green color, say for example, green color. Points are here. Now, can we separate these two? See, this is no, clearly we cannot now, as it is, we cannot separate, because these green lines exist in between. Now what do you do? We go for, this is x, this is only one variable, that is x. Now let us calculate, use a function y is equal to distance from a point, whatever point, distance. It can be any distance, my dear friends, some function of distance of an x. No, suppose for example, you take this as the main point, and you point, our point is this, and our center point something like this. So xi minus xc, that gives, this gets 1, the minus 1, this gets minus 2, something like this. Now, if you plot a graph between x and y, of course, it may go into this side. whatever it is, right? It may even go to this side, so need not to get worried, right? Right. For example, now if you calculate, if you plot this, now these points will come like this, and these points will definitely come like this, and our green points will definitely come over here, and again our points will come again here. Now in this case, if I draw a line just like a line like this, no, I am not able to write no in a straight fashion, but we can definitely write a line like this, so which separates all our things and all our classes in a perfect way. So this is called this scenario. The idea is very clear, my dear friends. So if you draw a thing, it may come like this. You have to take this distance in such a way that it comes like this. Then you can easily separate this just like a small. Then these are all separated. This is one class, this is the other class. See, now we can apply SVM. Hope you understood, my dear friends. This is called SVM, support vector machine. This can be even if it is one variable, only one variable, then if you can increase by using some formula, if you add some direction, some dimension. See, dimension, if you add a dimension, automatically we can get a linearly separable things. If you take two variables, right, if you want to separate them, something like this. This is a two variable. This is two variable. So if you want to separate this, by looking at this, you may come to a conclusion that there may not be separable. But if you add one more and add after adding, now if you take some z where no a formula of these two, then they can be easily separable. Then see on it, this is what. This is called support vector machine. Let us talk tomorrow about the remaining things. Thank you.